Hello everyone, in this video we are going to learn Venn diagrams and operations on sets. This is a Venn diagram, and in this Venn diagram universal set U has been represented by a rectangle and the subset of the universal set U has been represented by a circle. So why we use Venn diagrams? What are Venn diagrams? Let's learn. Most of the relationships between sets can be represented by means of diagrams which are known as Venn diagrams. Venn diagrams are named after the English logician John Venn from 1834 to 1883. Venn diagrams consist of rectangles and closed curves, usually circles. In Venn diagrams, the universal set U is represented by a rectangle and its subsets by circles. In Venn diagrams, the elements of the subsets of the universal set U are written in circles, and the elements of the universal set are written anywhere in the rectangle. The elements which are in the circles are also the elements of the universal set U. So you can see that this is a Venn diagram, and in this Venn diagram the elements of the universal set are written inside this rectangle, but the elements of the subset of universal set U are written inside the circle, only in the circles, not out of circles. So here set A is the subset of universal set U, and the elements of set A are written in this circle, not out of these circles. It means the elements which are out of this circle are not the elements of the set A. The elements which are inside this circle are also the elements of the universal set U. Hence we can say that the elements of the universal set U are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are the elements of the universal set U. But the elements of set A, which is the subset of the universal set U, are 2, 4, 6, 8 and 10. So you can see that in roster forms, universal set U and its elements are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And A, which is the subset of the universal set U, the elements of set A are 2, 4, 6, 8 and 10. You can clearly see that set A is not equal to set U. So we can write set A is not equal to set U. But you can again see that set A is the subset of set U. Because set A is not equal to set U, but set A is the subset of set U, implies that U is the superset of set A. U is the superset of set A. Now we will learn some operations on sets, and with the help of operations on sets we will learn Venn diagrams also. So we have learned how to perform the operations of addition, subtraction, multiplication and division in earlier classes. Each one of these operations, I am talking about addition, subtraction, multiplication and division. Each one of these operations is performed on a pair of numbers to get another number. For example, if we want to add one number to another number, then we take at least two numbers. I mean a pair of numbers. So suppose we take 5 and 7 as a pair of numbers, and if we perform the operation of addition, then we write 5 plus 7 and we get 12. We get 12 as the sum. So 12 is the sum of 5 and 7. And how we have get 12? We get 12 by performing the operation of addition. Similarly, if we perform the operation of multiplication by taking these two numbers 5 and 7, then we get 35 as the product of 5 and 7. Similarly, there are some operations which, when performed on two sets, give rise to another sets. In the same way, like numbers, in the same way, if we take two sets and perform some operations, then we get one single set, which is the result of the operation performed. These operations of which we are talking, these operations are: number 1, union of sets; number 2, intersection of sets; and number 3, difference. Let's try to learn first operation of sets, union of sets. Here we will learn union of sets, which is the first operation on sets. Suppose we have two sets A and B. The union of set A and set B is the set which consists of all the elements of set A and all the elements of set B. The common elements being taken only once. The symbol this is used to denote the union of two sets. Suppose we want to find the union of set A and set B, then we write A union B, but symbolically we write A, this symbol, and B. This represents A union B, and we read it A union B. Now try to understand union of two sets with some examples. Let the elements of set A are 2, 4, 6 and 8, and the elements of set B are 6, 8, 10 and 12. Now we find A union B. If we find A union B, then we take all the elements of set A and all the elements of set B, but the elements which are common for set A and set B must be taken only once. In set A and set B, elements 6 and 8 are common, because elements 6 and 8 are contained in set A, and elements 6 and 8 are also contained in set B. That's why 6 and 8 will be taken only once in the union of A and B. So the elements in the set which represents A union B are 2, 4, 6, 8, 10 and 12. Now we take another example to understand the union of two sets. Suppose we have a set A and set B, and the elements of set A are A, E, I, O, U, and the elements of set B are A, I, U. Then the elements in the set which represents A union B are A, E, I, O, U. Now you can clearly see that A, E, I, O, U are the elements of set A. Hence, A union B indicates set A. Hence, we can say that A union B is equal to set A. Here we can see that B is a subset of set A, implies that set A is the superset for set B. But why set A is the superset for set B? Set A is the superset for set B because B is the subset of set A and A is not equal to B. Hence we can say that set A is the superset for set B. Hence we conclude that if B is the subset of set A and B is not equal to set A, then A union B is equal to A. Or if A union B is equal to A, then B must be the subset of set A. Remember one thing more. If B is a subset of A and B is equal to A, then A union B is equal to A. And also A union B is equal to B. Implies that A union A is equal to A or B union B is equal to B, because here set A is equal to set B. So in place of A we can write set B, and in place of set B we can write set A. Now we can define union of two sets. The union of two sets A and B is the set C, which consists of all those elements which are either in set A or in set B, including those which are in both. Union of set A and set B can be written in set builder form like this. A union B is equal to the set of all x such that x belongs to set A or x belongs to set B. This is the set builder form for union of two sets A and now we will learn Venn diagrams for union of two sets. This is a Venn diagram, and in this Venn diagram this complete rectangle represents universal set U, and set A and set B are the subsets of this universal set U, and set A and set B are shaded, and also they are intersecting each other. Because these sets A and B are shaded, therefore this shaded portion represents A union B. This shaded portion represents A union B. Here set A and set B are intersecting. That's why this portion which are intersecting represents the common elements which are common for set A and set B. The shaded portion represents A union B, and the area which indicates the intersection of set A and set B is used to represent the elements which are common for both the sets, set A and set B. Suppose this is one circle which represents set A, and this is another circle which represents set B. Both the circles are intersecting. That's why we get this shaded portion is the intersection portion, and in this intersection portion only those elements are written which are common for A and B. To understand this, we take an example. Suppose we have two sets, set A and set B, and a universal set U. So the elements of set A are 1, 2, 3, and the elements of set B are 1, 3, 4. Hence the elements of the set we represents A union B are 1, 2, 3 and also 4. 4 must also be included. These are the elements for that set which represents A union B. Now let the elements of the universal set U are 1, 2, 3, 4 and 5. Then with the help of Venn diagram, we represent set A, set B and universal set U like this. 1, 3, 2 are the elements of set A. 1, 3, 4 are the elements of set B. 1 and 3 are the elements of set A and 1 and 3 are also the elements of set B. Hence, 1 and 3 are those elements which are common for both the sets A and B. That's why the portion which represents the intersection of two circles will be used to write the elements which are common for both the sets. Now we learned some properties of the operation of union. Some properties of the operation of union are commutative law, associative law, law of identity element, and phi is the identity of union. Fourth, idempotent law, and fifth, law of universal set U. So here we will learn 5 laws which are called properties of the operation of union. So here we are going to learn 5 laws which are called properties of the operation of union. So first law is commutative law. Commutative law says that A union B is also equal to B union A. It means A union B and B union A are same. There is no difference. Associative law says that union of A and B union C is equal to A union of B and C. And law of identity element, here phi is the identity of union. Law of identity element says that A union an empty element is equal to set A. Fourth, idempotent law says that A union A is equal to A. A union A is equal to A implies that set B union set B is equal to set B. And the fifth law, law of universal set U, says that universal set U union set A is equal to universal set. I hope you have learned all the things which I have explained in this video. Don't forget to watch my next video in which I will explain 2 other operations related to sets, intersection of sets and difference of sets. And for your kind information, I want to tell you that if you are interested in mathematics of higher classes like class 12th and for G mains and G advanced, then go to the channel MathsHiMaths, whose link is given in the description, and subscribe that channel also. And if you have not subscribed AR Study Circle, then subscribe AR Study Circle for the mathematics of class 11th and for English videos and for the videos of science for classes 9th and 10th. Thanks for watching this video.